Let's just solve this question. From a triangle ABC with sides 13, 14 and 15, a triangular portion GBC is cut off where G is the centroid of triangle ABC. So let's just assume this is given triangle A, B and C. The sides are given me as 13, 14 and 15. A triangular portion GBC is cut. G, B and C. G is some point here where G is the centroid of the triangle. We know centroid is the intersection point of all the medians of a triangle. So let's just assume this is centroid. This is centroid. So this portion is cut from this triangle. This is the centroid. I know centroid is the intersection points of the medians. These will be medians. So this is the intersection point of all medians. So this portion GBC is cut from this triangle ABC. I need to find the area of remaining portion of triangle ABC. That is, area of triangle GBC is subtracted from the area of triangle ABC. Now, using the property of medians, that a median divides area into a triangle into two equal areas. So let's just assume this area be X. So this area will also become X because this is median. It is passing through centroid. So this area is X. This area is also X. Now, carefully, if I join this side, so this is also median. So area of for this triangle, let's just assume A, B, and let's just assume it as point B. I know this point G, that is centroid, divides each median in the. There is property of centroid that centroid divides median into the ratio 2:1. So centroid will divide each median in the ratio 2:1. So taking the triangle A, B and D, I know it is divided in the ratio, or the area of this triangle is divided in the ratio 1:2. So if 1 is X, the area of this triangle is 2X. Also, this is median. So this and this area is equal. So this is also X, this is also X. And similarly, I know when I divide or when I join each vertex with the centroid, it divides the triangle into how many? 1, 2, 3, 4, 5, 6 equal areas. It would be X, it would be X. Now, the area of triangle GBC is giving me as 2X, and area of triangle ABC is giving me as 2 into 4 into 6X. So leftover part, when I subtract this GBC from this ABC, would be area of quadrilateral ABGC to be 4X, 6X minus 2X. Now I need to find the area of value of this X to get the area of this quadrilateral. Now, using Heron's formula, I can find the area of this triangle ABC because all three sides are given. Area of triangle ABC to be Heron's formula is under root semi-perimeter into semi-perimeter minus one side, second side and third side. I know sides given are 13, 14 and 15. Sum is 27 plus 10. 37 plus 5, 42. So semi-perimeter would be 42 by 2. That is 21. So area would be 21 times 21 minus 15, 6. 21 minus 14, 7 and 8. So it would be 7 square, 3 square and 16, 4 square, square root. So area of ABC, area of triangle ABC is square root of 7 into 3 into 4. This is 21, 1 into 4 is 4 and 8, 84. So area of triangle ABC is 84, which is 6x. So 6x is 84. So x is, from here, I know x is how much? 40. If x is 40, so area of this quadrilateral ABGC, which is asked, is 4x, that is 56 units. So correct answer to this question is 56 units.